Okay, so let's try to study this problem partition equals subset sum. The problem say that given a nums array, okay, so given a nums array, if you can partition the array into two subsets, so into two subsets such that sum of the elements of both the subsets, so sum 1 and sum 2, so sum of the elements of the both the subsets are equal or not. So whether we need to check whether sum 1 equal to sum 2 or not. Okay, so this is one partition 1 and partition 2. Okay, so let's take an example over here. So we have 1 5 11 5. Okay, so we can partition it such that so 1 5 5 will be in one subset 1 5 5. Okay, and another would be 11, right? So if we sum it up, then 5 5 and 1, so what will be? It will be 11, and over here it will be 11. So this is, let's say this is sum 1, this is sum 2, and sum 1 equal to sum 2. So if both are same, so it will be true. Okay, now let's take another example. So this is example 1, this is example 2. Okay, so over here 1 2 3 5. Okay, so over here in the example 1, what we had, like we had 11 and 22. So 22 was total, so that's why we could divide it into 11 11, right? But over here you can see, like we have 11 over here, so can we partition it? So if we partition it, then what will be, like everyone will get 5.5 5.5. I mean, how can we derive to that, right? So if we take only 5, and then 3 and 2 will take 5, okay, and 1 will be still be remaining, right? So we cannot partition it, right? So we can straight away say, if the sum, if the total sum is odd, if total sum is odd, then return false, because you cannot partition it, right? So basically now total sum is 2 into subset sum. So what we had, so 22 was total, so 22 is equal to 2 into 11. Okay, so now subset sum is equal to total sum by 2. Okay, now if we can find, so like right, we have 22 total. Okay, we have 22 total. Okay, now if we find 11, like if we find 11, like sum of the subset, like any subset which is having a sum of 11, then we can clearly say that other subset will be having sum as 11, right? We can partition into two subsets such that the both the partition having equal sum, right? So the logic is, so if we find a subset with total sum by 2, then we can say we can partition the array into two subsets with equal sum. Okay, now before before jumping to the approach, I would highly recommend that you watch my previous video on a previous lecture on 0-1 knapsack, because that is the base problem and we are just trying to solve a pattern with that problem actually. Okay, so that is the base and this is the child, you can say. Okay, so now so over here this subset sum, so this subset sum we can say, over there we had weight, like we had a capacity, finite capacity. So this subset sum, we can say that this is the remaining capacity and we have array is given. Now we need to find a sum, like we need to pick elements such that it's equal to the subset sum. Okay, so over there we are making combinations, like whether a number can be part of the subset or it cannot be part of the subsets. We are having include and exclude case. Over here also we'll be having the same, so we'll be having the same include exclude case and we'll be following same recursive logic over here. Okay, so now let's try to write code for this. So we'll be having a function, okay, and it will accept two parameters, index and target. Over there we had index and capacity. Okay, now at any point if we reached if we say like target equal to 0, so we are moving from right to left. Okay, so at any point if target is equal to 0, return true, because if the target becomes 0, then we can make the subset with the target sum, we can make the subset with the target sum. Okay, but at any case if index is out of bound, so if index less than 0 or target becomes negative, okay, then we can simply return false. Okay, now we'll be having two cases like we had in the 0-1 knapsack. Okay, so first we'll be having the exclude case. So exclude case, what we did, we moved to the next index without doing nothing. So index -1 and target will remain same. Okay, include case we initialize with 0, but over here we initialize with false. Okay, and before including we'll check that whether the current element is lesser than or equal to the target. So if nums of index I've taken int over here. If nums of index less than or equal to target. Okay, so if it is less than or equal to target, then include would be f of index -1, f of index -1, target minus nums of index. Okay, and over there we are doing maximum, but over here we need to check whether include or exclude is returning true or not. So return include or exclude. Okay, and finally if we call this function, so let's say n is the length of the nums array. Okay, and if we call this function f of n-1 and target is, let's say target is total sum we need to derive, so sum of the elements. Okay, sum of the elements in the array, and if we pass total sum by 2, okay, then this logic is done, so this code is done. Okay, but is it accepted? Obviously no. But what will be the time complexity for this? So time complexity would be 2 to the power n, because a number can be either part of the subsets. We are making two choices, either it can be part of the subset or it cannot be part of the subset. So that's why it is 2 to the power n. Every node, every point you are having two decisions, okay, include or exclude. Space complexity would be O of n, so we'll be having the auxiliary stack space of O of n because you are using n numbers over here. Okay, now if you draw the recursion tree, then we will find that there are overlapping subproblems. Okay, and if you have overlapping subproblems, then which approach comes to our mind? So it is dynamic programming, right? So we'll try to optimize with top down and bottom up. Okay, so let's try to code this up. So first we'll declare a variable to get the length of the nums array. Okay, then we'll get the total. So total would be sum of the nums array. So we'll check, like initially we'll check if total cannot be if you cannot partition it into 2 with equal sum, then straight away we can return false. So if total modulo 2 not equal to 0, if it is not divisible by 2, then you can simply return false. Okay, next we'll declare a DFS function. It will accept two parameters like before, index integer, target would be integer. Now over here will target would be total by 2. Okay, and over here what it will return, so return type would be boolean. Okay, all right. Now base case we will write later. Okay, first we will write the exclude case. Exclude case, what we do it, we move to the next index, so it will be DFS of index -1, target will remain same. Okay, include case, what we did, include case, we in knapsack we initialized with 0, but over here we will initialize with false. Okay, and the same thing we'll do, like if nums of index less than is equal to target, then only we can subtract, right? Then only we can subtract and move to next index. So over here include will be DFS of index -1, target minus nums of index. Target minus nums of index. Okay, so okay, and then in knapsack what we did the maximum, but here we need to do return a boolean over here. So either include will return true or exclude will return true. Okay, now let's write the base case over here. So if index, first we'll write if target is equal to 0, so by any chance we reach to target, so then it will be return true. Okay, we can make the subset sum. Okay, else if index less than 0 or target less than 0, then we cannot make the subset sum. Okay, equal to target, so basically in that case it will be return false. Okay, so this is done. Now what we will do, we'll call this function. Hope everything is good. Include, exclude, include false, nums target minus, return include exclude, and over here return DFS of index will start from right, and what will be the target? Pass the target. Okay, let's check this. It is running fine. It's running fine, but if we submit, it will obviously it will give us a TAT. Okay, so what will be the time complexity as discussed before? So it will give us so this particular will give us so it will give us time complexity of 2 to the power n, because either a number can be part of the subset or cannot be part of the subset. So two choices we have. Space complexity would be O of n. Okay, now this is done. Now what we will do, we'll declare a DP table. We can use the LRU cache as before as well, but let's do the DP table way this time. Okay, so first we'll declare DP table, and it will initialize with -1 star, then it would be target +1. Okay, so this is the inner array, and for item in range n is done, and then we'll pass, what I'll do, we'll pass the DP over here, DP over here, DP over here. Okay, so functions we passed, and then what we'll check over here, so if whether you already memorized the value or not. So in this case, if DP of index target not is equal to -1, return DP index target. Okay, then over here what we will do, we'll need to memorize the value. So before returning, what we can do, so over here we'll do DP of index target is equal to include exclude. Okay, over here we'll pass the DP, okay, while calling the function. Okay, and over here, and then finally we'll return DP of index target. Okay, so hope everything is good over here. Target return true, exclude DP on the target not equal to -1. We checking whether the value you already memorized, and then you are memorizing the value, and finally you are returning the value over here. This is return DP, every function we pass the DP array. Okay, alright, let's try to run this. It's running fine. Accepted as well. Okay, so what will be the time complexity? So this particular function time complexity would be so rather than 2 to the power n, it would be n into target will be total by 2, so you can just denote that it is the it is total. So basically T is basically total target, and space complexity would be O of n only. Okay, but there will be an auxiliary stack space of O of n. Okay, so this is O of nt because we are using a 2D repeatable. Okay, and then we are having auxiliary stack space over here. Okay, so this particular T is basically so T is basically what I'm trying to say, T is basically total by 2, so total by 2, I mean this is total by 2, but effective would be if we remove half, so it will be effective would be n into T, right? And so that's about it. So this is top down we discussed. Okay, now let's try to do it in the bottom up way. we'll copy this over here. Okay, so do we need all this? No, we don't need all this. Okay, so over here initialize with false. Okay, all right. Now over here what we'll do, so if target is equal to 0, then we return true, right? So you can say if dp of 0, so we declare a 2D dp table over here. Okay, so now we'll say like dp of 0 is equal to true. So if target is 0, then for the first item we can simply say that it is true. Okay, so we can make a subset. Okay, now next we need to run a loop. So for I in range or index in range n. Okay, then another loop will run over here, will run from 1 to n. Okay, 1 to n. Another will run another so for t means target, so for t in range 0 to target plus 1. Okay, so now we'll copy the recurrence over here. So what we said over here, exclude would be dfs index minus 1 target. So over here exclude would be dp of index minus 1, it will be t. Okay, so dp of index minus 1 t. Okay, and include will be initial false. Okay, then we'll check if nums of index less than is equal to target less than is equal to t. Then what we'll do, include would be dp of index minus 1, dp of index minus 1 target minus nums of index. So it will be t minus nums of index. Okay, now what we will do over here, dp of index t would have the value of include or exclude. Okay, this is fine, and at the end we will return dp of n minus 1 target. Okay, let's check whether we have done any mistake over here. dp 0 true, for index in range 1 to n, for t 0 target plus 1 include false, include index less than equal to t, include t minus nums of index, dp of index minus 1, include exclude. Over here this is fine, I guess. Let's try to run this up. Okay, so include, there is a spelling over here. Okay, what it is saying, exclude is not defined. Oh man, exclude. Okay, it's running fine. Okay, so time complexity for this would be O of n into t. T means total sum. Okay. And space complexity would be O of n into t. Okay. So we remove the auxiliary stack space over here in this approach. Okay. Can we still optimize this as we have done before in this knapsack? I guess we can. Okay. So let's try to optimize this. So first we will optimize with the help of two 1D array, and then we'll try with one 1D array. So over here we'll see so this will declare as, so why you can optimize, because over here you can see like we are just referring the previous row and the current row and assigning the value in the current row, right, like before. Okay, so over here what we can do, so we can declare this, we can reuse it, so this would become this. Okay, current would be false, so we declare two 1D arrays. Okay, initialize with false. Okay, so this will become previous as we have done before, because we have to initialize the initial row. So initial row, and this is the initial row, and this is the index. Okay, 0th column index. Okay, we initialize with true, because if the target is 0, we can make a subset. Okay, subset sum equals to target. Okay, so then over here what we can do, so this TP of index minus 1 would be previous, this is current. Okay, so previous, this is previous. Okay, exclude include previous, and then after that this would be previous of target. Okay, and over here what will be, it will be we need to swap it, so previous would be current. Okay, hope we are good. Right, you are passing. Okay, so what will be the time complexity? So time complexity would be same, it will remain same. Okay, and space complexity, we are using two 1D arrays with target or total by 2. Okay, so it will be O of t. Okay, now can we still optimize this with one, rather than using two 1D array, we can still use one 1D array like before. Okay, so we'll comment out this, we'll previous, so we'll keep it previous. Over here what we'll do, so this should be previous, and we need to reverse it, right, reversed as we explained before, because this particular loop might have calculated this already, so but we need to calculate the previous row value, so that's why you reversed it. So you are now will start from right to left. Okay, so this we have reversed it, so we'll start from right to left, include this previous would remain previous of remain same, this swapping is not needed anymore, so we'll comment out this one. Okay, previous exclude previous, include t minus previous, include exclude. Hope everything is fine. Okay, awesome. Okay, it's running fine as well. Okay, so I mean time complexity will still remain same, space complexity will remain same, but we have removed another extra 1D array and we're just using single 1D array over here. And if you have any difficulty to understand, please refer the knapsack 01 knapsack problem. So that is the base problem actually. Okay.